I think we can start. I would like to say welcome everyone, and I encourage you, since we are not a very big group today, to feel free to turn on your camera so our speaker Rémi Duflot can see with whom he will be interacting today. Our speaker Rémi, he's now a postdoc in Finland at the University of. Oh, you would have to help me with that, Rémi.
Yeah, University of Jyväskylä.
Jyväskylä.
Yeah.
Thank you. Rémi holds a PhD in landscape ecology from the University of Rennes in France, and since he obtained his PhD, he has worked as a postdoc researcher in different locations, mainly on the relationship between landscape heterogeneity and biodiversity. But he is also interested in landscape planning, using spatial graphs for modeling, habitat networks, and connectivity. And currently, he's investigating the potential benefits of management diversification for biodiversity, focusing on boreal forest ecosystems. Well, besides the scientific activity, I would also like to mention that Rémi is IALE member since 2011, so quite some time he's been with us. And he has also received a IALE Student Travel Award in the past. So after these brief informations, I invite Rémi to give the presentation. Rémi, the floor is yours. And what I would also like to do is to encourage you, the participants today, to post any questions if you have during the presentation, post them in the chat, or maybe hold them until Rémi finishes the presentation and we could have together a discussion. So, okay, Rémi, the floor is yours. I think I might need to make you a host. And you can, after you share screen, please make me a host again so that I can let other people join the webinar.
Okay, can you see the slide in full screen now?
Yes.
Yes. And you need to be host again. Host.
Technical information that we have to
participant.
deal with. Probably it would have been live, it would have been, give me the microphone, please have the microphone back.
Okay, so I think you are host again, so you can.
Yes, thank you.
In. Okay, so welcome everyone. Thank you for being here. It's nice to see some people interested in forest management. So I will show you some thoughts I have about my current project about boreal forest and how we can increase biodiversity in them by using new forms of management or diversified form of management. So I cannot change the slide. Yes, it is right now. Okay. So as the background of this project is something that you mostly know. Biodiversity is declining in all ecosystems, or nearly all ecosystems globally on the planet. And as landscape ecologists, we think and we know that landscape heterogeneity and connectivity of habitats are very important drivers for biodiversity in human-dominated landscape. That is, landscape where humans are having a very strong influence on the patterns of habitats and their quality. Specifically on forests, there are new pressures expected because of this bioeconomy, the concept of bioeconomy, where we want to make a sustainable economy based on resources, natural resources that are renewable. So we want to use the forest to make renewable energy, to have material, for example, for construction. And this is mostly directed against climate change. So we want forests to store carbon and to use them as an energy and material that is renewable and that is not emitting more carbon. So we expect and even desire greater extraction from the forest. The thing is that forest biodiversity is already at risk, and the forest biodiversity represents a large part of the total biodiversity in the world, if you think of the tropics, for example. And it's also very important in forest-dominated countries. So I am from boreal area. So in boreal countries, usually the forest dominates the landscapes. So this an example to show this is this graphics about the area of different forest types in Finland from 1950s. And we can see that there was a shift in the structure of the forest with a large increase of young forest and decrease of very old forest. So this pattern is also true in many other places. And this, of course, have consequences on the quality of habitats and biodiversity. So I will start with a definition of heterogeneity just to make sure everyone is on the same page with that, because I will use this concept a lot. So I define heterogeneity as the variation of ecological conditions in space and in time. So we can distinguish two dimensions of heterogeneity: the composition, which describe what elements are in the landscape and in which proportions. So for example, here landscape C is more heterogeneous than landscape A. And then the second dimension is the configuration. So in landscape A and B, we have the same habitats, the same area for the brown and yellow, but they are very differently organized in the space. So the most heterogeneous landscape is landscape D, with more different forms of elements and complex organization. And these two dimensions, composition and configuration, can also change over time. So going back to the forest, in forest ecology, we consider that habitat diversity is very important for biodiversity because there are very various species groups with different ecological niches. And often these species are specialists. So they absolutely need a particular habitat to be there. So they rely on the presence. So biodiversity is high when you have all these habitats there. So this habitat diversity is a consequence of the natural disturbances and the following succession. So there are many types of disturbances, and we can make three categories that are not sharp categories, but more like a gradient of disturbances. So we talk about stand replacing disturbances, for example, large fires or windstorms that will destroy most of the forest. Almost 100% of the trees will die on the spot. Then you have the cohort dynamic, which is a less intense disturbance, for example, low intensity fires or windfall that will destroy partially the forest. So maybe half or 1/3, 1/4 of the trees will die with this kind of. So the new generation will arrive on the gaps created by this. So you have different generation on the same place. And then you have a gap dynamic, that is the smallest type of disturbances. It can be only one tree dying because of it was weakened, and so a stronger wind will break this particular tree or group of tree. And in Finland and boreal forest, we also talk about snow, that snow can be heavy on trees and will also destroy some trees. And these different sorts of disturbances operate at different spatial and temporal scales. So that's this graph on the side. We can see that large events are usually more severe, but also less frequent. And then there is a gradient with a smaller event, the gap dynamics. They are smaller in size, less severe, but much more frequent than the others. And the very important things here is that these disturbances are not exclusive, so they can overlay over each other, and they have effects that can last for several decades. So during several decades, some other event can impose on the remaining of the other one. So this creates a very wide diversity of habitats over time. So that's the natural state of a forest. But then we can think of heterogeneity in managed forest. So the strong effect of forestry is that it suppresses, at least partially, the natural disturbance, and it replaces it with human-induced disturbances. And these disturbances are usually harvest, and in boreal forest, it's often clear cuts. So all the trees are harvested at the same time. So this forest operation reduces the variation of disturbances in their intensity and their frequency. They are more standardized because the human activities are more standardized. So this lowers the diversity of events and probably the diversity of habitats. So it homogenizes the forest habitats at the stand level and at the landscape level. So the habitats tends to look similar because they experience the same types of disturbances. So we can say that intensive forestry reduces habitat quality and diversity compared to natural forests. So this is an example with a comparison between Northern Europe and Canada. And they have studied the characteristic of disturbances between natural forest and managed forest. I will not go through all this table, but it's for all these lines, we can say that the managed forests have lower gradients of disturbances. They are more regular, and the events happening are more similar to each other compared to natural forest. So this is something that is have been studied for many years, and in the 90s, I think, I'm not totally sure of that, but in the 90s there was this idea that we should manage differently the forest in a more sustainable way and get inspired from the natural disturbance dynamic to imitate it and recreate the habitats for biodiversity. So the idea here is to use management options that will recreate structures that are important for biodiversity. So that would be deadwood, large trees, large old trees, vertical structural diversity in the forest with different strata or trees of different sizes and heights, and tree species mixtures as well, because I didn't say it, but often the managed forest also tends to have lower tree diversity. So there have been a lot of work to define different sorts of management that will be a bit less intensive, or at least will create these structures. So we can kind of define two extremes in the gradient. So that would be for Finland, the business as usual, the recommended management, which is quite intensive with planted forest, monocultures, and a rotation of 80 years and clear cuts at the end. So that's very directed. You have this recipe that is applied in most of the forest. And the other extreme is absence of management. You do nothing and you let the natural dynamic happening. And in between, the idea was to create some variation in the management so that we have more micro habitats, and more higher quality habitats for biodiversity. So some of these examples are here in this table. So we can extend the rotation so that the trees have time to grow larger and bigger. We can also do nothingings, so that's the intermediate cut before the final harvest. So then the forest is more dense and the trees can die naturally instead of being extracted. So there are usually more deadwood in this forest. We can also do no clear cuts at the end. So you harvest the trees regularly, but without cutting all the forest at the same time. So these are different options that are considered for the boreal forest, especially in Finland. One thing that is missing here could be the use of controlled fire. In some regions, it's very much used to create habitats that are specific from the post-fire habitats, so burned deadwood or very open habitat. So there is this development of many alternative management options, and they are studied and they are often successful in increasing biodiversity. But it seems that using a single alternative management regime at the landscape level will increase biodiversity locally, but it will also homogenize the habitats because all the forests will be managed the same way, so they will tend to have the same characteristics. And this is a problem because, I've said before, there are antagonistic relationships between different species groups. So for example, in the saproxylic species, some species are very specific and specialized on early successional stage, so dry and a lot of light, and others are specialized on all-grown forest, so no light, very humid. So these species cannot be at the same place. So you need to have all these habitats, and this is similar for plants. So I have here an example of my own research. So these are 6 indicator species for biodiversity in boreal forest. And I have looked at the proportion of suitable habitats in the landscape when it's managed entirely with the same management type. So the y-axis is the management types similar than what I presented in the table before. So we can see that, for example, capercaillie or Siberian flying squirrel, they like absence of management, and they also like long rotations because they need old trees. But other species like lesser spotted woodpecker or this other bird species, they prefer continuous cover forestry, so no clear cuts. And we think that's because they require the presence of deciduous trees, and this style of management favor these deciduous trees. And another example here is a tree-toed woodpecker, another bird that prefers the absence of thinning. So it's another type of management where it's maximizing its proportion of suitable habitat because it's very dependent on deadwood and this management for deadwood. So here there is a sign that there is some kind of complementarity between the management regimes, and it's not always the same species that will benefit from the different styles. So this comes to the idea of management diversity, as it is unlikely that a single optimal alternative management would benefit all biodiversity at the same time. So I define management diversity as the combination of a variety of management approaches at the landscape scale. And after this long introduction, I will go through 5 hypotheses on how management diversity could increase and benefit biodiversity in the landscape. So the first hypothesis is habitat diversity hypothesis. I was already talking about this. So we expect that forest management diversity will increase landscape level biodiversity through beta diversity. So if we consider a landscape with 3, 5, or 9 management style, we can consider that they will create different types of habitats, and therefore more types of habitats will increase biodiversity globally in the landscape. And this effect will be stronger if the habitat or the management types are equally shared in the landscape. So for example, there is here landscape that is dominated by this yellow management type, and the effect will be stronger if the dominance is less strong. So one example of that, it's again one of my results. I have made these simulations and looking at the habitat availability for the same 6 indicator species. And I have made landscape using increasing the number of management types in the landscape. So 1, 2, or 12, up to 12 different management types in the landscape. And we can see that more management types increases the diversity and increases the availability of this habitat availability. But we don't necessarily need all the management types. So for example, if we select 5 alternatives that are that have the strongest potential for biodiversity, we can have up to 44% increase in the habitat availability and also less variability in the results. So the second hypothesis, I include time variation in it. So it's spatial and temporal heterogeneity. So I say that asynchrony in management timing enhances the long-term stability and availability of different habitat types. So I will explain this with the figure. So in this landscape, I have put different colors for 3 management types, and then different shade or different lighter or dark colors for the different stage of development. So in the landscape, originally I put all the stages and all the management types, and then the next time step, maybe 30 years later, the forest has changed, but all the habitats are still there. So some forests have been harvested and are going back to the early stage. Some other forests have been growing and are now more mature. So we can say that all the different options are still there. So at all time, all the habitats created by this management and stages are there. The opposite, if you have a synchronous landscape, the forest is at the same stage originally. So between time 1 and 2, all the forest is ready for harvest, it's harvested, and then all the forest is at the early stage. So you have a strong dynamic in the habitats, availability at the landscape level. So the species associated with this late stage will have trouble to survive at this intermediate time because the habitat is not there anymore. And then it will come back when the rotation is over. So that's an important aspect that is not very much studied, is like how the habitat availability can vary in time because of the dynamic of the forest. And then you can also try to break this synchrony by bringing more heterogeneity by spreading the harvest. So for example, for the same landscape, if I harvest only a part of the forest, I create more heterogeneity at this point, and I wait to harvest the rest of the landscape. And then slowly there is more different stages of the forest over time. So I put an example here because it's always easier with an example. So again, this is from Sweden. So they have simulated the habitat availability for bird species, tree creeper, and they have made simulations over 150 years, and they look at the habitat availability over time. So this dark line represents the current management, if we continue the management as it is now. So first there is an increase in the habitat availability, and then a strong decrease because a large proportion of the forest becomes available and ready for harvest. So at the beginning of the study, a large part of the forest is very young. So after 70 years, this forest has grown up and is ready for harvest. So at this time, there is a drop of habitat availability, and then it's increasing again. So you have this cycle following the harvest cycles. So they have tried with this dashed line is when you extend the rotation time. So when the forest is ready for harvest, then there will be an extension before the harvest actually happens. So they extended 20 years or 50 years, and the first effect is that it increases the habitat quality. So there's a lot more habitat available for the species. But still, again, when the cycle is done, then a lot of forest is available for harvest, and then it's harvested, and there is a drop in the availability. So that's when the species could be at risk for extinction if it goes below some threshold where the species cannot survive. So the idea, and they didn't test that, would be to mix different rotation length and do it. It will probably result in a curve that would be in between these 3 lines. And so the cycle will be smoother, and there will be a less dramatic drop in the availability of habitat at this time, and it will be more stable through time, and probably that's beneficial for the species. So I was talking mostly now about the composition of the landscape, but I was also thinking about the configuration. So how do we organize in space the different management style? So this is the interspecial hypothesis. So I hypothesize that spatial adjacency or proximity between stands with different management increases biodiversity. So the idea here is that the 3 different management styles are spread all over the landscape so that they cover all the different nuances or gradients that can be here. For example, if you have topographic differences, like a valley and a mountain, you would want to have the different management type and the habitats they create at the different, following also these gradients. On the contrary, if they are aggregated, for example, here, all the green management would be on the top of the mountain and all the purple management would be in the valley, and that's less variability and less habitat differences available in the landscape. Another important feature is the creation of edges or proximity between the different management styles. And we know in forest ecology that edges are specific habitats, and some species prefers to be on edges between 2 different forest type. And this can also create complementation processes where the species needs the presence of 2 different habitats for survival, for example, for nesting and one for feeding. So this proximity between different habitats created by the different management regimes could also be beneficial for biodiversity to some extent. So I have an example of that too. So this is from a plantation forest in southern France. And they found that butterfly richness was higher in the edges than in the interior habitats for different type of forest. And so it shows that the edge between 2 habitats is a habitat in itself and is important for many species. So they have studied all the taxa in the same region, and they found positive effect of heterogeneity, and especially the proximity between diverse habitats and the positive effect of edges. So they studied birds and also carpet beetles. So they concluded that there is complementation process happening where species use 2 habitats and they need the 2 habitats to survive. And they show that, but mostly between different edge classes, so between mature forest and open habitats. They also found that there might be a negative effect of fragmentation. When you have more edges, you also have less interior habitats. So that could be a problem for some species, and they found a few bird species that were having negative response to that. So I'm now to the 4th hypothesis, and I will move now more in between managed and natural forest. So this is the natural forest hypothesis, and it's very clear in the literature that we need heterogeneous and managed forest for the complete biodiversity conservation. It's a consensus that alternative management types cannot fully replace the natural forest. So we have to include absence of management in the management planning as well. So that's why it's here, because we plan not to do things in the forest. So what I added here is that protected forest must represent the natural gradients. And this comes because I noticed, and many people also document, that protected areas are not randomly distributed. They are following some gradients themselves. So for example, in Finland, most of the protected forest is in the north. So historically, it's because they have been less used by humans, but also because they are less productive. And it's the same in the south. Only 3% of 3 or 5% of the forest is protected, but these forests are usually located in non-productive soils. So there is this bias in the representativity of this protected forest. So not all habitats are actually protected by that. So it could be about climate, like in Finland. It can be topography. Some countries have more protected areas. In the mountains, it can be also because of the soil So this is acknowledged in the forest management planning, and usually there is this multi-scale sustainable management planning. For example, this triad approach where we split the landscape into 3 zones with different purposes. So one is ecological, so that's the protection. One is multiple use with extensive management, and one is mostly dedicated to production with intensive. So this is an example from Canada. They have made this zoning for one region, and they have split the forest into these different management zones. And what's interesting here is that the south is temperate forest and the north is boreal forest. And you can see that they have spread the different zones across the entire area, so that all sorts of forest types are represented in all the zones. So that's the hypothesis I made, that we need to protect also the protected forest should also follow the natural gradients so that all habitats are protected. And this 5th hypothesis is linked to the first one. It's a temporary corridor hypothesis. So I assume that management diversity can create non-permanent connections between protected forests, and this can be for multiple species. So here is a landscape with 3 protected areas, and in the commercial forest in between, we apply alternative management that create habitats. So I choose here to illustrate with deadwood-rich early stage, so sun and dry and deadwood in it, and the green is the absence of the presence of large old trees. So some species would be able to cross the commercial forest from protected area to another in these temporal corridors. I say temporal because still they are managed forests. So at some point there will be operations and the habitats will change. And so the connection will not be permanent. But it could be sufficient for the species to travel from or to disperse from one protected area to the other at some time, and that could be beneficial for biodiversity. So they are examples of that. It's the contribution of key woodland habitats, so that's a legal term in Finland, in Sweden as well. So these are commercial forests, but they have high value for biodiversity because they haven't been intensively used in the past. So they can contribute to the connectivity of protected forests. So this figure represents 3 regions in columns and 2 sorts of forest habitats. And the line shows the connectivity of the protected network, the network of the protected forest, with and without these key woodland habitats. And in some cases, we see that there is a high contribution of these key woodland habitats to the connectivity of the protected areas. So the idea here is more to protect some sites. The key woodland habitats is to protect sites that have a high value for biodiversity, and alternative management is to create new sites with high value for biodiversity, though. So we can make this parallel, and probably they will also benefit connectivity as these woodland habitats. So I made a conclusion for each of these hypotheses to summarize all what I was talking about. So there are theoretical and empirical arguments on beta diversity and management diversity. It's highly probable that more different style of management would create different habitats and increase biodiversity at the landscape level. But there is no formal validation of that, because it's hard to manipulate landscape and create actual landscape with different level of management diversity. And also, it's probable that not all management types are needed and has value in all regions. For example, controlled fire will not have much value in regions where the forests are not subject to fires naturally. So we don't necessarily need to to use the full range of the management style that are possible, we can select more specifically which one are useful. I was also talking about the topol dynamics of the forest, and this is a phenomenon that is very well known and very well studied for a long time, especially the disturbance and succession theory is very strong. But there are very few studies on the variation of habitat availability over time and its consequences on management, how we can make management planning that will account for this potential variability over time. Usually these are very static, the planning for management are very static and they don't account for this time variability. There are few examples of complementation processes between edge classes, so that's also related to time variation. And there are not so many about different management regimes. So this is not easy to study because this would mean to have a landscape where you have different types of managements and they are adjacent or not adjacent, and you study how the species travel between them or how they affect biodiversity. So this would be interesting because this would tell us if we need to do interspecial or not, if we need the different management regimes to be close to each other, or if we have to aggregate them. So the spatial organization of this can affect biodiversity or not, and we need to study that more. And finally, there is a consensus on the need for unmanaged forest, but we still need to evaluate their representativeness so that they fully protect all sorts of habitats that are possible in the forest along the different gradients. And there are, however, very few research about spatial topol connectivity. So the connectivity of protected areas, this is studied, but again, this is static, and the contribution of the commercial forest to that is not very much studied so far, but it's also very recent. So that's also probably the reason why. So thank you for listening, and I hope you will have some questions. I would be happy to answer.
Thank you, Rémi, for the presentation. It was very nice insights into management approaches to forests. I encourage the participants to ask the questions directly if they want to. Otherwise, they can use the chat. Also, before some of you leave, please don't forget to fill in the survey that we are doing about the webinar today. Oh, you can find the link in the chat. Well, until participants decide about the questions, I have one for you, Rémi. What would be, in your opinion, or how things would work out if the management approaches you presented would be implemented in real life from I don't know, an institutional perspective? Or how do you think forest managers would be open, or are they open from your experience to certain types of or certain approaches as linked to your hypothesis?
I'm not so aware of how managers can react. What I hear is that they are often reluctant to changes. So they like to follow a plan that is very well structured and easier to organize. So I think, especially in Finland, that the sector is very well organized and has a tradition to operate in one way, and it's hard to convince that we can change some management. That's the perception I have from my colleagues mostly. So there is a big debate about this clear cutting and continuous cover forestry, not only in Finland, also in Central Europe. And so we would need very strong evidence before they can be convinced and perhaps forced to adopt different styles of management.
I noticed that you highlighted in the take-home message that more research is needed on all 5 hypotheses you mentioned. Maybe what would be the least studied hypothesis in
Yes, I also try to highlight that there are a different stage of investigation. I would say that the management diversity, there is quite a lot of comparison between different management styles. So with the burning or non-burning, green tree retention is very much studied. The continuous cover forestry also start to have some good results. It's quite new, so they are not long-term, but there are early results about that. And it's almost all of these studies, they found that the species communities are different when you apply different management types. And they sometimes include also the natural forest, and they often also differ from the natural forest as well. So they are, this is something that is a lot more studied than other aspects I mentioned. Especially this complementation is very strong in other landscape fields, other ecosystems, but in forest I haven't seen much of that. There are examples in Australia but on mammals, and also in France about these birds and butterflies. I don't know other examples. It doesn't mean they are not existing, it just means I don't know them. So I would say that this is a lot less investigated, and also this contribution to connectivity, the 5th hypothesis, this is something that is not much.
Well, considering that at least in Europe, the plan within the European Green Deal is to increase the surface of protected areas. I think many more studies will come since forest is one of the habitats or ecosystem that is often preserved. So maybe finding different approaches to forest management would be something to consider. I see there are no questions in.
Yes, I think one from Françoise. I mean or Vivek as well. The hand is.
Okay, the hand is okay. Okay, please, Françoise.
Hello, so it's Jacques Baudry speaking. Thank you, Rémi, for this presentation. It was interesting, and I think your point that nature reserves are on special places and do not cover all the physical gradients is very important, because people really lack protection of biodiversity on good fertile soils, probably. Another remark is a remark from all the people, you know. There was a book in the 80s, last century, by a guy named Harris, The Fragmented Forest. You read it? Because he discussed some points that are very similar, and he also put the idea of cutting forest, so the succession stages are distributed over space. You have the more or less clear cut, and then you clear cut 10 years after nearby. So you have the succession forest going around. And maybe, I don't know, well, you know, we don't have much forest, so we don't follow the literature on forest. So maybe he produced some data on this. So the name is Harris. We can send you the references. Probably the book is not on the internet, so it's but I think it's very similar in terms of. And I think also Jerry Franklin was a PhD student of Richard Form, and he did some work also as well on this topic.
Yes, thank you. I think Franklin is a name that I have encountered many times,
Yes.
but I didn't know about Harris and this experiment. Yes, it's true. I came up with this by reading articles, many, and it's sometimes hard to go far in time. So sometimes the old things can be very good, but it's not always easy to access it. Or yes,
But we can send you the book. Mark in Canada did also experiments in forest.
sorry, the sound is not so
The sound is not
very good.
It's François computer and the sound is not good. Marc-André Villard in Canada did the experiment of cutting forests at different ways, and he's working birds.
Okay, thank you for the reference.
Thank you, Rémi.
Thank you. Maybe we can go to the next question from Vivek.
Yeah, hi. I am Vivek. I'm a researcher from India. I work as a research fellow in MS Swaminathan Research Foundation. I work as a soil resource conservation researcher in a state called Odisha in India. So I wish to thank you very much for this exciting research. My research is completely focused on agroecosystems, how diversification could help, management diversification in agroecosystems could help reduce the, instability in the production systems of agricultural landscapes. US is almost much similar to the ideas that is coming from the landscape ecology of agroecosystems. The only doubt I have is, are there any long-term study sites related to forestry management diversification, whether biodiversity data collection is happening for continuously for decades long? Are there any studies like that? And that is my first question. And I have a small, I just want to introduce this paper to you. The title is Agricultural Diversification Promotes Multiple Ecosystem Services Without Compromising Yield. They also give convincing results from the second order meta-analysis through their research. Very exciting paper. Maybe I'll write it in the chat after the discussion. This is very exciting. So diversification approaches are being catched up in different production landscapes. That is very exciting to see. Thank you very much for your research.
Yes, so first, it's not a coincidence that there are similarities with agroecosystems, because this is where I come from already.
Oh, okay.
And then about the question about long-term monitoring, yes, the disadvantage of forest ecosystem is that it's very long process. So there are long-term monitoring in forest. It's called usually national forest inventories, and there is one in Sweden, one in Finland, one in France, one in Germany, etc. And they are trying to have representative plots where they measure the forest repetitively. So I think the Finnish and Swedish are the oldest. Maybe Germans is also quite old. But the thing is that they are still managed with the most frequent management style. So they are usually not landscape studies, so it's just a plot or a group of plots. And they don't necessarily represent the different management options, especially when they are kind of new management things that we are thinking of, like continuous cover forestry is almost absent in Finland. So it's very hard to find a place where to study that. But there are also research sites from universities and forest institutes, and they are manipulating. They have tried already controlled burning or green tree retention, and this even deadwood enrichment. That's what they create actively more deadwood. So they have made these comparisons already with. Sometimes they are many years, maybe 10 years. I think of Eastern Finland, they have maybe 10, 15 years time, but it's still small compared to the full rotation. So that, well, I think to test this hypothesis, we need a mixture of simulations and observations, and that's something I try to discuss now. But this is the regular tools of forestry, basically, that observations and a lot of simulations, because it's saving time.
My master's thesis itself is a simulation study about evenness and those kind of stuff. That was very exciting, about pollinators in the cropping systems. I think the presentation was really exciting, and I have come across similar forestry research papers which speak about diversification, importance of diversification of management practices. But I think your presentation today was really thorough and it gave very insightful ideas for me. Thanks a lot.
Yeah, thank you. But yeah, you can send the reference in the chat.
No, I'll in chat I will write it.
If you want, that would be nice. Thanks.
Yes, well, speaking about the chat, I would also like to share with those of you that don't know already Rémi's different channels to which you can reach Rémi, or Rémi's work, his Google Scholar account, follow him on Twitter, or see his publication records on ORCID. If there are no more questions, I think we can close the webinar of today. I would like to thank everyone for joining, especially I was happy to see that Vivek from India, and I've seen in the survey that several other people outside Europe join. I am aware that they make a certain effort to join. It might be evening or early morning for them, so we really appreciate that. Thank you once again, Rémi, for accepting to give the presentation today, and I wish you all the best in the future.
Yeah, thank you for invitation. That's nice, and thank you for the questions and familiar faces.
I'll send the reference.
Yes,
in the chat.
thank you.
Yeah. Thank you. Thank you, Simona. Thank you, Rémi. Yeah.
Thank you. Goodbye, everyone.
Yeah. Well, do we have anything else to talk about? No, probably.
No.
No.
I think
Okay. So, thank you.